All right, so summative number 5 is going to have a few repeating sections on it and then a couple of new ones that should be a good time for us. All right, so this first section, this is 6.4, part 1, or A, I think we called it in the grade book. So these are the fraction exponent questions, and this is a retest, so make sure you capitalize on this retake. I'm looking at number 1A, and I'm seeing we have some coefficients that I just need to take care of, like regular old numbers. So 9 times 5 times 2 is going to be, let's see, a 90. Oh, I didn't see the 2 on my answer key originally. Let me go change that. So those are not exponents, and therefore you don't have to worry about exponent rules when it comes to coefficients. All right, let's just fix that. Good call, Abruzzo. All right. So now we are not done because we have some bases we have to combine still, and we have to determine how we do that. So x to the negative 2/3 later on times x to the second. And what you're supposed to do with the exponents is you're supposed to add them together. So we encourage you guys on your calculator to take negative 2/3 and add 2, and then hit math enter to bring it back to a fraction. Let's see, that becomes x to the 4/3. And then you're going to use the same property on the y's. We have y to the negative 5th and y to the 3/5. And when you add those together, so I'm going to run out of room here, you get y to the negative 22/5. Is that right? Gross, gross, gross. All right, so problem here is that you can't have a negative exponent. That's one of the rules. So this term, this y to the negative 22/5, is going to have to move to the denominator. So the 90 can stay, the x to the 4/3 can stay, but now we have a positive exponent on the y to the 22/5, since you moved it to the correct side of the fraction bar. All right, so 1b is very similar. Go ahead and practice that one on your own. And you should be able to check the answer key to see if you did it well. Hopefully my answer key doesn't have a mistake. All right, number 2a, you have a bunch of stuff going on here. So first thing I notice is this parentheses set. I'm supposed to distribute this 1/2 power to each term, and because they already have existing exponents, that means I'm supposed to multiply those together. Now be careful, there is still an x to the negative 3/2 in front. That's not being affected by that distribution. I'm just going to kind of leave it there for a moment. 4 times 1/2 on my calculator or my brain would give me x to the second, and then 0 times 1/2, well, 0 times anything is still a 0. So at some point in your math, you need to remember that anything to the 0 power is just a 1. So this is like these guys times a 1, so this whole term can just kind of be forgotten. It's not going to do anything, but I do need to collect my x's together because I'm going to take my exponents and I'm going to add them together. So on my calculator, negative 3/2 plus 2 would be 5/2. Now if you went ahead and wrote times 1 like this, there's nothing wrong with that, it's just not necessary. So most simplified answer here for us would be x to the 5/2. All right, so 2b, very similar. Try that one on your own and check the answer key. All right, be very careful on 3a. We had some problems with this on the last test. Remember, these are coefficients. So you're not going to do exponent rules because they're coefficients. And if you're not sure what to do with them, just type in 14 divided by 28 and then hit math enter. And it'll reduce that to a fraction for you. It should be 1/2. So you can write it like 1/2, that's fine. And then remember your exponent rules here. When you're dividing your bases like this, you're supposed to subtract. You just got to be careful what you're typing in, guys. You're taking negative 2 and you're subtracting a negative 2/3. So on your calculator, type that appropriately. And when you do, let's see, I think you get x to the negative 4/3. And that's in the numerator right now. And then same thing for the y's, you're going to subtract the exponents. So you have 1/4 minus a negative 3/4, which will be y to the first. So as far as final answers go, this is not ours because this x to the negative 4/3 is going to have to move. So 1 times y to the first, I'm just going to write down a y. And then 2 is still in the denominator, and now it's joined up with x to the positive 4/3 power. So I'm pretty willing to accept any answer that's equivalent. Just make sure that you run through your little checklist. No negative exponents, everybody's collected, and there's no parentheses in your final answer. 3b is very similar to 3a. Go ahead and try that one on your own, and please check your answer in the answer key. And everyone's favorite property, anything to the 0 power is 1. So the answer to that question would have been a 1. Now, just to kind of make sure we're not confused when we get to our test. if you end up with this problem, so like, whatever to the 0 power, and then there's also something like x to the negative 2 in front of it. Well, this part here, x whatever to the 0 power, this is a 1, but x to the negative 2 is not affected by that 0 power. So if this was your question, so totally separate question here, guys. Yes, this is a 1, so you'd have like x to the negative 2 times 1, and then you'd have to take that x to the negative 2 and move it to the denominator. So it is possible that even though part of your problem is raised to the 0 power, maybe that doesn't mean your final answer is just a 1. You got to be real careful there. Like for instance here on 4b, the answer does come out to a 1 because, oops, come on pen, or not, I mean whatever, this term right here, this stuff to the 0 power, this green part, this is a 1. So this is like 1, and then it's still being squared. Well guys, 1 squared is still going to come out to a 1. So that was a really boring question. I think the one on your test has a little more flair to it, so be careful. Alright, remember we need to remember how to write in the different forms. So this is radical form, I need to write it like this guy. This is exponent form, I need to write it like that guy. The formula, if you want to call it that. Remember, it's base and then raised to the power divided by the index. And it has to go in that order, so you got that little backwards on your test. So here, the base is x, the power is 7, and then the index is the number that identifies the type of root, and if there's nothing in the index, we assume it's a second root. Remember, nothing means there's a second root. There's no such thing as a first root here. So on this question, it's going the opposite direction. You're going to write your base of b in the radical. And then as far as what type of radical that is, that would be this number here. So this is a cube root of b raised to the 5th power. So your 5th power can be in with the b here, or you could have written it as the cube root of b, all of it raised to the 5th power. So either one of these answers works out great for that question. Just be really careful that you understand the formula, and that you also realize that there's no such thing as a first root. That was a problem we saw in the last test. So here you can use your chart. Remember, have that purple chart handy. And we have a couple square roots here on 6a and b, and we're going to expand them apart if we can't break them down. Otherwise, we're going to do some highlighting. So, square root 32 is not a perfect square, but I could break it up into, and I look through my list of perfect squares, the biggest number that divides into 32 is 16. So I'm going to break it up into 16 times 2. And then remember, this is a square root. So if I could leave the exponent, I'm going to, otherwise I'm going to break it apart. So x to the 7th, I'm going to break this apart. I'm going to call it x to the 6th times x to the 1st. Some of you have taken to taking a little shortcut here, and I love that you've taken the shortcut. If you don't like this shortcut and you want to keep going x to the 2nd, x to the 2nd, x to the 2nd, you are welcome to do that. And then for y to the 4th, that'll divide evenly, so I'll just leave it. And then for z to the 3rd, we're going to break that up into z squared with a z to the 1st left over. So then I come through with my highlighter, and I mark up things that are going to simplify, and whatever I don't mark is going to stay in the radical. So I'm going to be able to reduce that, and that, and that, and that. And everything else is going to be stuck in the radical. So square root of 16 is a 4. Square root of x to the 6th would be x to the 3rd, which is the same x to the 3rd you would have gotten had you broke this apart into a couple x squareds, or 3 of them. Square root of y to the 4th is y squared. Square root of z to the 1st is z. And then everything else that I didn't just highlight is stuck. So we have a 2, an x, and a z stuck in the radical. Oops, I said z. There we go. There's our final answer there. Nice, nice, nice. All right, I know those are pretty challenging, so give those a go. I'm going to leave the b's for you to do on your own and check the answer key to make sure you're okay. So this next one, be careful. We have a 4th root this time, so make sure you're looking in the proper list. So in the 4th list, 16 is a perfect 4th. So I'm just going to leave that as a 16 for now. And then everything else here divides evenly, so I actually don't have to break anything down. That's great news. So everything's going to get highlighted, which means nothing's stuck in the radical at the end of this problem. So you're going to reduce this, and this, and this, and this. Here we go. 4th root of 16 on that chart is a 2. 4th root of a to the 12th is a to the 3rd. And 4th root of c to the 4th is c to the 1st, or you can just write c. So there will be a time possibly on your test where everything reduces out of the radical and there's no radical left. Alright, this is a new concept. Everything so far has been old. This is a new one. So factoring, you can use your flowchart. Flowchart has the multiplication table on the back. Feel free to use it on your studying, plus also during your test. So, top of the flowchart says, look for any common factors. When I look at 8a, I notice we do indeed have a common factor. All of these are divisible by a 2. So you can take the 2 out of the problem, and when you do that, you're left with, divide everything by 2, so you're left with x squared minus 8x minus 20. Now, I have to keep moving down the flowchart because I don't think we're done. This question, this black trinomial I wrote down, that is a reverse foiling question. So, when I look at that, I go to come up with what times what gives me x squared in the first position. So that's going to have to be x and x. And then, what times what in the last positions will give me negative 20. So I got some options. I know the signs are plus and minus because in order to multiply to a negative, I need one positive and one negative. But for 20, 4 and 5, 10 and 2, 20 and 1. Those are all my options, and I think about, okay, I need to add up to negative 8 in the middle of my problem. So I'm going to kind of mess around with the factors and check, but I'm thinking if I make this a negative 10 and a positive 2, that'll work out. But I'm not done because I still need to check. That is a negative 10x on the outside arch. This is a 2x on the inside arch. And when you add these together, you do get negative 8 in the middle. So this is my final answer. Notice I've shown my teacher that I've checked the arches. I've left that 2, that common 2, out in front of the problem. Make sure that it doesn't disappear. And make sure that it's fully factored. Some of you try to muscle through the reverse FOIL without taking the 2 out at the beginning of the problem. At some point, the 2 has to come out of the problem. So you might as well take it out at the beginning. It makes your life easier. Alright, same thing here. We have a common factor of 3 that you're going to take out of the problem. And when you divide everything here by a 3, you get x squared plus 5x plus 6. Now remember, factoring is all about perseverance and guessing and checking and revising. So you'll know if you got it right when you leave the question because you check it. Starting with, alright, first terms have to multiply together to give me x squared. So those have to be x and x. My last terms have to multiply together to give me positive 6, and I notice there's all plus signs in my problem, so I'm going to go ahead and write down plus signs. But 6 could be, 6 and 1, could be 3 and 2. So the last piece of the puzzle, I have to remember my middle arches have to add up to 5. So if I chose plus 3 and plus 2, my arches should check out. Let's see. We have a 2x on the outside arch. Come on. And then we have a 3x on the inside arch. And what do you know, guys? When you add those up, you do get 5x in the middle. So this is one of the rare times in math when you can leave a section or a question and go, man, I totally got that right. All right, top of the flowchart again, guys. Look for a common factor. This one does have a common factor again. So you always want to take that common factor out first. They could both be divided by 8. And man, it must be your birthday or something, guys. This is that special pattern. This is the difference of squares. So whenever it's a subtraction problem of two things that can be square rooted, it's that really nice factoring pattern that works out, that good twin, evil twin pattern. So all you need to remember is how the pattern works, and it's on the flowchart if you forget. So the twin aspect of it is you taking the square root of each of these. So the square root of x squared would be x and x, and then the square root of 9 would be plus 3 and minus 3. So those are my favorite questions because once you recognize that it's that pattern, then you don't have to think real hard at all. All right, back to the top of the flowchart. Looks like we do have a common factor of 3. Let's take 3 out. And that leaves me, oh, that's boring, x squared minus 9. It's going to be the same problem, remember? So that was dumb. All right, 3 times x plus 3 times x minus 3. Sorry about that. My bad. So notice that common factor we took out is still there in your answer. Don't let it go away. Okay, so at first I thought I had a common factor on number 10. I thought I had a 5, but when I look in the middle, 26 cannot be divided by 5. So this is one of those reverse foiling questions that you just have to kind of muscle through, and it might take you a couple of guesses and checks and revisions. So we have some good news. This first term is prime, so there's only going to be one way for you to get 5x squared, and that's by using 5x and 1x. So I know that one's right. Also good news, on the end here, your last numbers have to multiply together to give you 5. And again, it's prime, so you have to use 5 and 1. But it could be 2 plus signs, or it could be 2 minus signs. So when I look ahead in the problem, and I look at the middle, I have to add up to negative numbers, so I'm thinking I need 2 negative signs. Now where you place the 5 and where you place the 1 is going to make a difference. And if I put the 5 here, I'm going to get 5 and 5 on my arches, which is not going to give me 26. So let's try putting the 5 here and the 1 here. Let's check. This outside arch is negative 25x. That says 5. This inside arch here is negative 1x. And when you add those together, you get negative 26x, which is what they wanted. So again, you get to leave the question knowing that you got it right. So go slow and take the time to check. I want to see these arches on everybody's test. All right, here, this one's, oh, we do have a common factor this time. Let's take that 4 out. So we have x squared plus 6x plus 6. Right? No, that's not 6, Abruzzo. 36 divided by 4 is 9. Wow, dyslexia. All right, so that x squared plus 6x plus 9, it is technically a special pattern, but it's that pattern we told you guys to kind of forget about. So x and x, and then to multiply to a 9, I'm thinking 3 and 3. Oh man, this is going to work out beautifully. X plus 3 times x plus 3. Now, I've had some kids say, hey, what if I wrote down, because these are the same factor, could I write down x plus 3 squared? Absolutely. So I don't care how you write your final answer, as long as it's equivalent to what my final answer is. So most of you will choose to write it this way. This way works as well. That doesn't often crop up. That's why that pattern wasn't really worth our time to memorize. That's why we didn't make you guys memorize it. Okay, this is an oldie. Domain and range. So give me a set of points that is not a function. So why is this not a function? You're going to need to create a set of points where one of the x's, at least one of the x's, is paired with more than one y. So like for instance, if we did 4, 2, and then, oh my gosh, my pen. 4, 3, I'm just making this up obviously. And, you know, just one more, like 5, 5. So the reason this is not a function is because x equals 4, and I want you to be real specific. X equals 4 is paired, and you could say twice. You don't even have to tell me who, but you can say is paired with 2 y values, is paired with y equals 2 and y equals 3. I don't care. Something that tells me this. What is the domain? You're just going to remember this is just a list. You're going to list out the x's, and then for range, you're going to list out the y's. So for domain, we would list out 4, you don't have to say it again, and then 5. And if you want to get fancy, for a list, you can use set brackets, or just don't do anything if you're worried about it. Now for your y's, this time you do have 3 different y's, so list them all. 2 and 3 and 5. And again, you can either leave nothing on them, or if you want to get fancy and use set brackets, you only use those set brackets when you are listing. All right, here they want you to create any function, so anything at all. So I don't have a lot of creativity in my life, so I'm going to do like this. Sounds good to me. And then it says, what's the domain? Well, remember domain is all the x's from left to right. So my domain starts here at -4 with a point, so we're going to have to use a bracket this time. And then it hits every single x value until it stops over here at 3. Now, because they have points, you need to use brackets. Squared brackets like that. Oh my gosh, pen, it's like possessed. Okay, the range, remember the range is the lowest y value to the highest y value. So the range, oh, I did a bad job of drawing because we have the same sort of numbers here. That's confusing. Range is how low to how high it travels. So it starts down here at -4 for y, and it goes as high as 3. So just keep in mind, you know, your answers will vary depending on what you just drew. So if you got fancy and you drew like a parabola or an absolute value graph, then you're going to have very different answers. All right, this particular one, let's assume that we have nice solid ordered pairs here at the end. These are not ending at really good spots, so I apologize. But the domain How far left does it stretch? Well, I don't know. Let's estimate that to be like negative 4.5. Since it has a point, you have to use a bracket. The range is positive 4.5. I'm going to go with that. These are estimates, so I might be a little off. Sorry, the end of the domain is 4.5. The range is, let's say, negative 2.5 is where it starts. And then it reaches all the way to a height of 2. Now notice, this ending point is not the highest point. You have to go to the highest point. So 2 is where we'll go. Again, that's an estimate, so if you disagree with me and you think it's really like 2.1, then more power to you. Good luck. All right, this is new stuff, absolute value graph. So remember, your absolute value function is y equals a times the absolute value of x minus h plus k. And the h is your horizontal shift. So that means right and left. The k value is your vertical shift. And then this a value is what we call a vertical stretch. So, and remember there's a built-in negative sign right here, so keep that in mind. I shouldn't make that blue though, it's black. Alright, so this one here has been shifted right 4, because that means right 4. And then this minus 2 is really like plus negative 2, so that means down 2. Alright, here, there's actually 3 transformations, so be careful. You have a negative in front of your function is a reflection. And if you want to win bonus points, you'll say over the x-axis. And then you have a 4 in front, which means you have a vertical stretch of 4. And then there's a plus 5 off to the side, so that says up 5. All right. You can try to confirm those by graphing them, but the idea is you should be able to inspect the formula and tell me the answer from there. So here, I want to know where the vertex is, and after you graph it, you should be able to tell me domain and range. So I always start by finding the vertex. Remember, there's a built-in negative right here, so this is really a negative 2, comma 3 for the vertex. So I'll go ahead and plot that point at negative 2, 3. And then your a value tells you 2 things. It tells you the slope of each branch, but you remember it's absolute value, so one slope is positive 1/3 and one slope is negative 1/3. But since the a value is negative, that means your absolute value is going to be upside down. It's going to be reflected. So you're going to be going ahead and plotting, let's see, down 1, right 3, and down 1, left 3. And totally going to draw this well, right? Oh man. There, got it the second time. Go me. It's like ripping a band-aid off. That's how my drawing goes. We just got to go for it. There we go. Not too bad. So domain goes forever left and right, so that's an easy one for us. That goes from negative infinity to infinity. But be careful on the range, guys. Remember, range is low to high, so this one travels down forever. So the range actually doesn't have a starting point. It goes down forever, but the range does stop up here at 3. And because there's an ordered pair there, you have to use a bracket. Order is important. Notation is important. Be very careful. And then our final question here, I'm going to give you a graph and you have to figure out what the equation is. So, just so we're clear, this is the origin right there. So the first thing I would figure out is where is this vertex at, because that's my h and k. So the vertex looks to be located at 1, 2, 3, 1, 2. So negative 3, comma 2. I kind of need to get my bifocals out to get that one right though. So at some point on your paper you should jot down where the vertex is. And then on your test, it's a little more clear than this. I went ahead and I put like dots on 2 points, so that way you can figure out the slope of the branch pretty easily. I already can tell that the a value is going to be negative because this absolute value is upside down. So what I usually do when I go to write my function is if I notice it's negative, right away I draw a negative sign because I always forget that one. But the slope, remember, is rise over run. So I'm seeing it move down 1, right 3. But if you went to the other branch, it would look like a positive slope. So you have to be careful with the a value being negative. So it's negative, and then 1/3 for the slope of the branch, or the stretch. X minus h would be x minus a -3. So it'll turn into x plus 3. And then plus k would be plus 2. This guy here. Okay. Sorry, that looks really ugly. Let me try to fix my writing a little bit. I think I'm making it worse. There we go. All right, so there's your absolute value function. All right. Well, good luck on your test. Make sure you're studying and checking all your work in the answer key. And best wishes to you.